Okay, more integration by parts. You probably started to notice that most of these are a combination of polynomial and trig, because what makes integration by parts useful is having one part of your integral that gets simpler when you differentiate it and one part that does not. So polynomial functions always drop by 1 degree when they're differentiated. That means they get simpler. Trig functions are an example of what we call a transcendental function, and one of their characteristics is they have an infinite number of non-trivial derivatives. In fact, the derivatives for these get more complicated as you go on because more threes keep popping out in this case. So the derivative for this would go cosine, negative cosine, positive sine, and it would just keep cycling like that forever. So we have a piece that's differentiable and that gets simpler when you do that, and a part that doesn't. That's essentially what integration by parts is custom made for. So I'll write the formula one more time to remind us what we're doing. U dv equals uv minus integral v du. They pretty much always use these letters, although, I mean, you can totally do integral adb equals ab minus integral bda if you want. It's not going to change anything, but from what I've seen, the standard in pretty much all books is to use u and v, unless you have to do this twice in a row and then you get to switch letters and it gets to be a bit of a brain twist, but I don't think they do that to you in this course. So the things we must find to make this formula work are a u, a du, a v, and a dv. I want the u to be something that gets simpler when it's differentiated, so the obvious target is our x here. If u is x, then du is dx. If that little piece is our u, then all this must be our dv. Cosine 3x dx. Its antiderivative, v, would be sine 3x, but because a 3 would pop out when you did the chain rule, we're going to have a 1/3 to catch that. So if you're happy with all that, the integration by parts formula says instead of this integral, you can do uv minus integral v du. So u, v, minus integral v. I considered putting that 1/3 outside the integral, and maybe I should have. Let's see how much of a bother it is leaving it there. And du is just dx. Okay, so this part out here is just a product. I'm going to shuffle the order and put the x in front of the sign because that makes it read nicer, I think. Not that it's a big difference. And then we have minus. Now we need the antiderivative. I'm going to take that 1/3 out front. Now that I look at that, it kind of bugs me having it in there. So minus 1/3. And now we have to do the antiderivative of sine 3x dx. Well, the derivative of cosine is negative sine, so the derivative of a negative cosine 3x would give us sine 3x, but then a 3 would pop out from doing the chain rule, so I'm going to need a 1/3 to make up for that. That's our antiderivative. And because this is an indefinite integral, we need our plus c on the tail end. So, finished version, 1/3 x sine 3x minus 1/3 times minus 1/3 is plus 1/9 cosine 3x plus c. All done. Now, if you're looking at that and thinking there's no way that differentiates down to x cosine 3x, I get you. These do look a little messy and like there's no way they could turn into something that simple. Let's try it. If we differentiate this, we're claiming this is the antiderivative, so if we differentiate this, well, a horrible thing happens. We get product rule from this first term. So we have to do, I'm going to call that the first piece and this the second piece. We get first times derivative of the second piece, which would be cosine 3x times 3. So that's first d second, plus, then we get second d first, which would just be 1/3, plus, now from this next term we get 1/9. The derivative of cosine is negative sine 3x. Then the chain rule goes off and we do the derivative of what was inside this and we get a 3. There's no product rule, so there's only one term there. The derivative of c is 0. So what does that clean up to? Here, the 3 and the 1/3 cancel. So we get x cosine 3x. From this term, we get plus 1/3 sine 3x. And from this last term, we get minus, right there. 3 times 1/9 is 3/9, which is 1/3 sine 3x. And look at that. 1/3 sine 3x minus 1/3 sine 3x. All that cancels out, and all that survives is x cosine 3x, which is exactly our integrand. This thing actually works.